Hi and welcome to John's Maths Book. In this video, we're going to be using L'Hopital's rule to calculate the limits of functions. If you like the video, then please hit the like button and I'd be delighted and honoured if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. If we look at the limit as x tends towards 4 of the expression x squared minus 16 divided by x minus 4, we see that x, as it moves towards 4, and if we plug the number 4 into this expression, we get 16 minus 16 divided by 4 minus 4, which is equal to 0 divided by 0. Now this is known as an indeterminate form. We could resolve this by simply factorizing the numerator, which would be x minus 4 multiplied by x plus 4. And then divide that by x minus 4. The denominator would cancel out with part of the numerator and it would leave x plus 4. So then we'd have the limit as x tends towards 4 of x plus 4. If we plug in the value of x equals 4, we would get that as an answer of 8. Similarly, if we look at the limit as x tends towards infinity, 4x squared minus 5x divided by 1 minus 3x squared. So as we can see here, as x tends towards infinity, the numerator tends towards infinity and the denominator tends towards minus infinity. So this again is an indeterminate form. Again, we could resolve this by looking at the limit as x tends towards infinity of, and then if we remove the x squared from the numerator, we get x squared multiplied into 4 minus 5 divided by x, and that would all be divided by x squared multiplied into 1 minus x squared minus 3. So the x squareds would cancel out, which would leave 4 minus 5 divided by x divided by 1 divided by x squared minus 3. So if we now look at what happens when x tends towards infinity, we see that 5 divided by x, so this part here, tend towards 0, and 1 divided by x squared here would also tend towards 0. So we'd be left with the limit as x tends towards infinity of 4x squared minus 5x divided by 1 minus 3x squared would equal, and what we're left with here is minus 4 divided by 3. L'Hopital's rule provides another way of helping to evaluate indeterminate limits of the form 0 divided by 0 or infinity divided by infinity. So if we want to find the limit x tends towards c of some function f of x divided by some function g of x, and where the limit as x tends towards c of f of x is equal to the limit as x tends towards c of g of x, and they both equal 0, or the limits of these two functions are plus or minus infinity. So if this is the case, and the limit as x tends towards c, the derivative of f of x divided by the derivative of g of x exists, then it is true to say that the limit as x tends towards c of f of x divided by g of x is equal to the limit as x tends towards c of the derivative of f of x divided by the derivative of g of x. So now let's look at this in action. Let's take the first example that we looked at, which was find the limit x tends towards 4 of x squared minus 16 divided by x minus 4. Now we found that this limit was indeterminate because it was 0 divided by 0. So let's use L'Hopital's rule to see if we can find this limit. So if f of x is equal to x squared minus 16, the derivative of f of x is equal to 2x, and if g of x is equal to x minus 4, the derivative of g of x is equal to 1. So we know from L'Hopital's rule that the limit as x tends towards c of f of x over g of x is equal to the limit x tends towards c of the derivative of f of x divided by the derivative of g of x. So in the limit as x tends towards 4 of f derivative divided by g derivative is equal to, now derivative of f of x is 2x, derivative of g of x is 1. So if we take x is equal to 4 and we put it into this, we get 8 divided by 1 which is equal to 8. So we've evaluated this limit using L'Hopital's rule. In our second example, we found that the limit as x tends towards infinity of 4x squared minus 5x divided by 1 minus 3x squared was also indeterminate, as it was infinity over minus infinity. So again, let's use L'Hopital's rule to try and evaluate this limit. In this case, f of x is equal to 4x squared minus 5x, and the derivative of f of x is equal to 8x minus 5. G of x equal to 1 minus 3x squared. The derivative of g of x equal to minus 6x. So in the limit, x tends towards infinity of f of x over g of x equals the limit x tends towards infinity of the derivative of f of x divided by the derivative of g of x. So the limit x tends towards infinity of the derivative of f of x, which is 8x minus 5, divided by the derivative of g of x, which is minus 6x. So we can see here, as x tends towards infinity, the numerator, as x gets larger, the numerator tends towards infinity, and the denominator tends to minus infinity. How do we deal with this situation? Well, we take the second derivative. The limit as x tends towards infinity of the second derivative. So the second derivative would be 8x minus 5 would leave 8, minus 6x, the derivative of that would leave minus 6. This would equal minus 4 divided by 3. So let's look at another example and see if we can evaluate the limit as x tends towards 0 of sine x divided by x. So when x is equal to 0, the sine of x is equal to 0 divided by x is equal to 0. So that's an indeterminate limit. So then if we apply L'Hopital's rule to this, we can say that the limit as x tends towards 0 of sine x divided by x is equal to the limit x tends towards 0 of the derivative of sine x, which is cosine x, divided by the derivative of x, which is 1. So at x is equal to 0, cosine of x is equal to 1, divided by 1, which is equal to 1. Let's look at another example. Let's try and find the limit x tends towards infinity, e to the x over x squared. So as we can see, as x tends towards infinity, we have an enormously large numerator and enormously large denominator. So we get indeterminate form of infinity over infinity. So let's apply L'Hopital's rule, see if we can evaluate this limit. So the limit x tends towards infinity of e to the x divided by x squared is equal to the limit x tends towards infinity of the derivative of e to the x, which is e to the x, divided by the derivative of x squared, which is 2x. So again, as x tends towards infinity, we have a case of infinity divided by infinity, which is indeterminate. So we can apply L'Hopital's rule yet again. We can say the limit x tends towards infinity of e to the x, this time divided by 2x, is equal to the limit x tends towards infinity. The derivative of e to the x is e to the x divided by the derivative of 2x is 2. So as we can see now, as x tends towards infinity, this evaluates to infinity. So as you can see, we can apply L'Hopital's rule multiple times to evaluate our limit. Other indeterminate forms that L'Hopital's rule might be able to help with are as follows: 0 times infinity, 1 to the power of infinity, 0 to the power of 0, infinity to the power of 0, and infinity minus infinity.